Welcome to Module 5, Lesson 10. So, just kind of jump into it. We're still doing the fractions, and now we're just making sure we understand that they're different sizes and be able to tell which one is larger and which one is smaller. So, going off of that, today is I can compare unit fractions by reasoning about their size. And just kind of giving a reminder, on a fraction, there is that line with a number on the top and a number on the bottom. As a reminder, this number on the bottom is how many pieces it takes to make one whole. Well, the number on the top is how many pieces you have. So top is the numerator, the bottom is the denominator, because it's down, like D for down, so denominator. And once again, the down is how many pieces to make one whole. Well, up here is how many pieces you have. And so, as I've mentioned before, typically in the realm of numbers, the higher number, the bigger the number. That's kind of how it normally works. 7 is bigger than 6. 10 is bigger than 5. 102 is bigger than 50. Those type of ideas. Typically, the larger the number, the larger its value. Now, fractions are a little bit unique because this bottom number almost plays an opposite role. The higher that number is, the smaller each piece is. To kind of give a visual example real quick before jumping into this, imagine that you were to have a pizza. And that is one whole pizza. So if you, by yourself, if there's one person, if you're one piece, you would eat that entire pizza. But let's say you and you're sharing it with one other person. Now, you cut that in half, get equal sizes, and now you both would get one of two pieces. So that would be 1/2 or 1/2. And that's how much pizza you would eat. But let's say you go out and you're eating with your family. My family consists of 4 people. So we cut the pizza like that. And now these are in fourths. So if I ate one piece, that would be 1 of 4. 1/4. Now you're seeing a pattern here. As we are cutting this more, the number is going up. The number of pieces are going up. But pay attention to the size of each piece. So I'm going to do it again. Now I have 8 pieces. So this is instead of 1/4, this is 1/8. Now, once again, what's happening to these pieces? Are they getting bigger or smaller? Because the number is getting bigger, but are the pieces getting bigger or are the pieces getting smaller? They're getting smaller. And so once again, I can continue, do it again. And now this is in 16ths. Those pieces are getting pretty small. Once again, we're going off the idea that all those pieces are the exact same size. Didn't draw it perfectly to scale, but we get the idea here. Let's say this was your favorite type of pizza. You love this type of pizza. And you're only allowed to have one slice. Would you rather have 1/16 of a pizza? Or would you rather have 1/4 of a pizza? And give you another visual right here. Ooh, my goodness, that was not a very good circle. 2 circles here. This would be a 16th. Like that, and this would be a 4th. So 4th would be one of those, 16th would be one itty bitty tiny bit of that. So if you're really hungry and this was your favorite type of food, you'd probably want to go with the 1/4 over the 1/16, because you want more of it. So lower number means bigger piece for fractions. But on the other case, let's say that this was a really gross pizza. You didn't like it. It had garlic, it had broccoli, it had onions, it had fish on it. I don't know. There's a whole bunch of things that you might not like on it. Maybe that sounds interesting to you. Not to me. Then you're like, okay, if I have to eat one piece, I like to eat 1/16 of a pizza, not 1/4. Because this, you have to eat a big piece of that one. Over here, at least, it's just a small, tiny bit. And to illustrate our point even further, I have a couple of fractions here. And I'm going to eat, just say that these are 3 equal, like Milky Way bars. Each one of these pieces, or wholes, I'm going to eat one piece from each one of them. So I'm going to eat one piece from here, one piece from here, and one piece from there. So once again, each one of this will be a fraction. Something over something. Starting with this top one, the denominator is how many pieces make the whole. This is the whole. So it's 1, 2, make the whole. And how many do I have? 1. I've eaten 1. Down here, I have 1, 2, 3, 4. 4 pieces to make a whole, and they've eaten 1. 1. Right here we have 1, 2, 3, 4, 5, 6, 7. and we've eaten 1. So once again, if you really enjoy this type of candy bar, you'd want 1 piece out of 2 versus 1 piece out of 7. But to say you really don't like this, then you'd want this one. Just kind of giving you the idea. If you have something that is this amount of space, this finite amount, the more pieces means each piece gets smaller and smaller and smaller because you're not adding more to it. You have a box, or you have that pizza, or you have a Milky Way bar, and if I'm sharing it with one person, sweet, we both get half of it. If I'm sharing with 4 people, I get 1/4 of it. If I'm sharing with 100 people, well, you're going to get like a teeny tiny sliver of that piece of candy. So typically, in fractions, if you want more, you want to be sharing it less, sort of a smaller number. So just kind of keep that in mind. Kind of going off of that, this is going to be kind of the practice to recognize when our fractions are bigger or smaller than one another. So we're going to go ahead and erase all this. And once again, if this is something that you're still a little confused on, when you see these problems, draw them out. That is a big thing here. So we're going to be doing greater than, less than, or equal to here. So if you're not sure what this means, if I have 2 numbers here, I'll give an example. If I have 6 and a 4 here, I use this number because 6 is greater than. It's the alligator mouth. The alligator always faces the direction it wants to eat. And the alligator is very hungry, so it wants the bigger thing. So 6 is bigger than 4, so it's going to eat the 6. Or I could have a number like this. I have 1 and 4. Say 1 is less than 4 because it's going towards the 4 instead. You read it like a sentence. Or I could say I have 5 equals 5. So this is kind of the idea here. So I'm going to give you guys 2 fractions, and I'm going to determine which one's greater, less than, or if they're equal to each other. So I'm going to say I have 1/4 right here. We'll just do some of the ones we just did, and a half. Now, for me personally, I like doing the circles because they're just, for me, they're easier to draw. But since we're newer to the idea of fractions, we're going to stick with like the bars, like the Snicker bar or the Milky Way bar, just so we can ensure they're visually accurate right now. So I'm going to draw a hole. Remember, both of these are being made out of the same sized object. So they might not look like it perfectly, but for the purposes of this, they are the same size. So this 4 is representing that it is broken into 4 equal parts, like that. This 2 is representing that this is broken into 2 equal parts. I have 1 here. I have 2 here. Which one has more? Which is a larger piece? 1/4 or 1/2? And if you're still not entirely sure, you can stack these on top of each other. So I'm going to move this one over here. Make it the same size. Cut into those fourths. All right, now that's a little easier to see. This one does not go nearly as far as this one here. So 1/2 would be larger than 1/4. Keep that in mind. So we're going to go ahead and try another one. If you need to look at that again, you're more than welcome to pause and rewind and look at it a little bit more in detail. We have another one here. As we could say, I have 1/3 and say 1/6. Which one is greater, the 1/3 or the 1/6? Now, once again, you might be very tempted just to lean one way or the other, depending on how you're viewing here. You might be like, okay, I see 6 over here, so 6 is a bigger number than 3, so that's the larger one. Now, pause on that just for a second, because we want to ensure that we're doing this correctly. So let's go ahead and draw these out. I'm going to stack them straight off the bat this time. This one's going to be the 3rd. This one down here is going to be the 6th. So 3 pieces. This one down here is 6 pieces. 1 there. 1 there. All right, which one's larger? The 3, the 1/3, because you still have the same amount, and so 1/3 of a piece is greater than 1/6 of a piece. Keep that in mind. I also at this point want to have you guys recognize that 1/3 and 1/6 can technically be written in another way. If you remember this type of unit form when we'd write out, if I wrote out 3 4s, this would mean 3 times 4, like that. Now, if I over here had 3/4 written like this, this would be 3/4. So, kind of base rule here, if it has THS, fourths, thirds is the D, but fifths, sixths, sevenths, eighths, ninths, it's the first number divided by the next one. Well, over here, you kind of get the idea. So, using that idea here, we're going ahead and ask this question: which one is larger in this situation? Let's stick with 3/4, fourths, and over here, let's say 2/3. Now, which one's greater? Once again, best way, in my opinion, if you don't see it right off the bat, which is okay, draw them out. So we're going to draw out both of these. Going to make sure their whole is the same. 3/4, that would be 3/4. 2/3 would be 2/3. Break this up into 4 equal pieces. This one into not many. All right, make sure it's as accurate as possible. This one I have 3 of them. 1, 2, 3. This one I have 2. Ooh, this one's close. And now this is why drawing these fractions out properly is very important. Because if you make them a little off, even by a little, it can get really, really close. But if I draw this line right here, you can see that 3/4 is just a little bit bigger than 2/3. Not by a lot, but it is by a little. So, and there's other reasons to recognize this as well. In decimal point, this is 0.75, all the way down here is 0.666666666, basically infinitely. But we'll talk about those at another time. But it's barely bigger. So drawing them out is very, very helpful, especially when they start getting close to each other like this. We're not going to be worrying too much about the multiples, like the 3/4 or the 2/3. We're going to be primarily sticking with 1/4 and 1/3. But I do want to show one more example on this to kind of show you what is possible. Doesn't that always happen, but this is why you need to draw it accurately so you can recognize this. Let's say I have 2/4 and 1/2. Let's draw these out. Make sure that they are the same in size. 2/4, make sure they're split into 4 equal parts. 1/2, make sure it's split into 2 equal halves. Now 2/4 would be 1, 2, while 1/2 would be there. If you look closely here, you notice something interesting. If I draw a line straight down the middle, is 2/4 larger? Is 1/2 larger? Or are they the same? For this one, they're actually the same. They are equal to each other. And this one, you actually can recognize in a certain way here. How many times does 1 go into 2? 1, 2. Twice. How many times does 2 go into 4? 2, 4. Twice. So, the 2, if you multiply 2 by 2, it will get to 4. Multiplied by 1, 2 by 2, it equals 2. So there's a lot of different ways we can do this. This is the primarily format that I would like you to focus on right now. The visual element is extremely helpful for this. Now, I do want to mention one more thing before letting you guys go, and it is recognizing when a fraction is larger than 1 whole. So, once again, the bottom number is how many pieces you need for 1 whole. The top number is how many pieces you have. If this top number is ever smaller than this bottom number, it is less than 1 whole. But as soon as this becomes like a 3, then I have 2 pieces make 1 whole. Well, I have 1, 2. Well, I have a third piece, so I need to make another whole. 3. So just kind of remember, if the numerator, the top number, is greater than the denominator, the bottom number, there are more pieces than the whole. So it's greater than 1 whole. So just kind of want to give you a reminder on that. But hopefully this was helpful. Hopefully you guys learned something, and I hope you guys have a great day.